In this video, we're going to start learning how to prove trig identities. In the past videos, we have seen some trig identities that were given to you, like the reciprocal identities, the ratio identities, or the Pythagorean identities. We didn't try to prove those that they were actually true. I just said, here you go, these things are true. But what we can do is we can use those identities, now that we are assuming they are true statements, if you trust me, we can use those to prove other things are true. Now I will say that most problems in this course and in other trig courses, if they're asking you to prove an identity, it's unlikely that identity is actually very important. Like looking at this first problem here, it is very unlikely that you're ever going to need to know that cosine of an angle times the quantity secant of the angle plus cosecant of the angle is the same thing as 1 plus cotangent. You're never going to quote that law in any future problems. It's not something that really matters. The whole idea of these proving of these identities is that you're getting familiar with how to use the known identities and your algebra skills to rewrite expressions, usually into something that is easier to see. And this is going to be especially important when you move on to like calculus, because there you're going to get this big mess as part of the problem. And if you can't simplify it down using your trig identities that you do know and your algebra skills, it's probably unlikely you can make any further progress on the problem. So yes, these ones are almost kind of busy work and then you're trying to prove something that doesn't matter in the grand scheme of things, but it is practice that will be essential for future problems. And so we're going to make you practice these a whole bunch in this part of the course so that you can get good at that manipulation. Now, the general idea when you're trying to prove an identity is you want to take one side of the identity, use your known trig identities and your algebra skills to try to rewrite one side to match up exactly with the other side. You don't want to do your normal algebra skills like add 1 to both sides or divide both sides by 2. Those are not things you usually want to do. You generally want to stick with one side and work your way to the other one. And usually you want to start with the more complicated side, try to do some algebra, and convert it into the simpler side. So this is what I'm going to do right here. So I have cosine x times secant x plus cosecant x equals 1 plus cotangent. What I'm going to do is I'm going to start by converting the secant and cosecant into sine and cosine. We know secant is the same as 1 over cosine, and cosecant is the same as 1 over sine. Again, we're only doing things to the left-hand side of the equation here. I chose to convert secant and cosecant into cosine and sine because I already had a separate cosine in the problem, and quite often it can be helpful to get just to sine and cosines. It's not always the best choice, and really through practice you're going to identify in different cases which is going to be the best method to solve the problem. In this one, we're going to take this and distribute cosine x in. So the first fraction, I have cosine x times 1 over cosine x is cosine x over cosine x. And then the second one, I go cosine times that. I get cosine x over sine x. And then the last step, cosine x over cosine x is 1. And then we use our ratio identity, cosine x over sine x is cotangent x. And since I was able to get to the right-hand side, I've matched it. That proves that the original two expressions are in fact equivalent. Okay, now let's take a look at the second identity we're trying to prove here. Once again, I have to decide to take one side and convert to the other side. I could choose to do it either left to right or right to left. I think the left side will be easier to start with, and that's just from personal experience. It's maybe slightly more complicated because there's 2 terms compared to the right side, only 1 term. I will go ahead and turn things into sines and cosines. So secant is 1 over cosine minus cosine. And then if I'm trying to subtract these two things, one's a fraction, the other one's not, so I want to get them to be both a fraction with the common denominator of cosine. That's using our algebra skills there. So then I have 1 over cosine minus cosine squared over cosine. Now they have a common denominator. I can combine them. 1 minus cosine squared x over cosine x. Then we know our Pythagorean identities. 1 minus cosine squared is a sine squared. And then to finish this off, that sine squared, I'm going to break it up into sine x times sine x. And I have 1 cosine in the bottom. And I do this because now it matched up the right-hand side, sine x times tangent x. And since I was able to get to the right side, I now have my answer complete. Notice that sometimes you can do something maybe 1 or 2 or even 3 steps, and sometimes it's going to take you maybe 5, 10 steps. Some of these can be pretty long and messy. For this third and final identity that we're going to prove here, there again, you can start with the left side or the right side. It's kind of up to you which way you want to handle it. When I see things in the denominator that have like a plus or a minus, in this case, the left-hand side, we have a 1 plus cosine x here. That kind of calls out to me that, hey, I'm going to want to multiply by the conjugate of the denominator. It's kind of like rationalizing here, even though there's no square roots. And again, that's just a trick that you kind of pick up the more of these you do. So I will start with the left-hand side. And I will go ahead and do as I said. I will multiply top and bottom by the conjugate of the bottom. So on top, I have sine x times 1 minus cosine x. I could choose to distribute that sine x in. Again, when you're first starting these things, that's probably what you would do, distribute that in. But since I have done a lot of similar problems to this, I know it's actually getting better if I don't do that right now. So I'm choosing not to. And then on the bottom, the reason why we multiply by the conjugate, when you do, just a reminder of algebra up here on the top, if you do a plus b times a minus b, you get a squared minus b squared. So on the bottom here, we have 1 plus cosine x times 1 minus cosine x. It's going to simplify to 1 minus cosine squared. And that's the well-known Pythagorean identity. 1 minus cosine squared is sine squared. And finally, one of the sines can cancel out top and bottom, leaving me with 1 minus cosine x over sine x, which is exactly what the right-hand side that we were going for is. And now we've proved all 3 of these trig identities. Again, this is something that you practice a bunch. You get used to those basic identities, the ratio, the reciprocal, and the Pythagorean. You use those over and over and over again until you get comfortable with it. And then in future videos, we're going to move on to other important identities that you can see and have to prove.